Well, hello guys, I'm Mr. G with another video. This time we're going to be solving a question or answering a question on physical and chemical chain for the grade 10s. This one was question 5 done in the Eastern Cape province in 2022. And I'm going to leave the question in the description below so you can answer before watching the video. The question says, consider the following reaction. And then you have a reaction F, or a reaction with copper plus oxygen give you Cu2O. I'm going to leave this one because it's one of the questions. Write down the chemical name of CuO. And this one will be copper 1 oxide. This one is copper 1 oxide. Now, how do I know it's copper 1 and not copper 2? This one is obvious 1 mark. Let's quickly do a small analysis here. Remember, when you combine the atoms to form a compound, you will have Cu and O2 minus. Now, Cu could either be Cu2 plus, let's do it a little bit further, Cu2 plus or Cu1 plus. If it was 2 plus, which is copper 2, then the numbers will swap to these places here and you will get CuO. Alright, but if it's copper 1, like the one we have in the example, will be positive 1 or still 2 minus always. When they change is Cu2O. So these two here, this little two here, showing me that it's copper 1. Because if it was not copper 1, then it will be nothing in there. Alright, so I hope this one is quite clear. It could be confusing. It could be confusing. If it's copper 2, then because the 2 of the oxygen, then this one will be nothing there. This one is copper 2. Okay, it's coming from there. Classify the above reaction as synthesis or decomposition. Now, decomposition is when they decompose or breaking, single compound breaking. So let's write it there. Decomposition is when a simple compound breaks. However, this one, it doesn't break, this one is forming. So this reaction here is synthesis, and if you select synthesis, you will get 1 mark. Alright, and let me show you there's 2 marks for saying copper 1 oxide. Okay, using a calculation, prove that the law of conservation of mass is valid for this reaction. All we have to do is to calculate the mass of the reactants and mass of the product, and if there is the same mass, then the reaction is the law of conservation of mass is valid. Okay, and here we are. So we're going to calculate the mass for the reactants. So reactants, what do we have? We have 4Cu plus O2. So we are going to go to the periodic table, guys, and we're looking for the mass of copper. Copper is there, is 63,5, and the mass of oxygen is 16. That is all we're looking for in the periodic table. So what we have here, 4, let's do it here at the bottom so you can see it. 4 times the mass of copper, remember, was 63,5 plus 2 times 16. Alright, this will give me that is equal to 286 grams per mole. Alright, so now we're going to do the same for the product. The same for the product. Now, what do we have in the product? The product, we have 2 Cu2O, and we have to substitute everything here. So it's a 2, and be careful, this is math, it's a 2. I'm going to open a big bracket and I'm going to say copper, which is 2 coppers, is a 2 times 63,5 plus 1 oxygen, which is 16. And then I'm going to start solving the things inside the bracket. So it's 2, and is now give me 127 plus 16, and this is going to be equal to 2 that multiplies. Let's open the bracket so you can see what I did. This one's 143 is the solution of in the bracket. So when I multiply times 2, I get 286. So this is equal to 286 grams per mole. And that is the answer. The answer is that one. The mass of the reactants is equal to the mass of the product. There we go. And that is the final answer of this question. And there are 3 marks, one for calculating the mass in the reactant for that substitution, one for this one, and one for the final answer to say that they are equal. Okay, so that is the answer for that question. Now the next question say 20 grams of copper completely react with 250 cubic centimeters of hydrochloric acid solution of unknown concentration according to the following balance equation. This one is now some stoichiometric. Define the term concentration. And let me show you something. The formula for concentration, which is in the formula sheet, is equal to number of mole divided by volume. Number of mole is amount of substance, right? So you can say amount of substance per unit volume and you will get the mark. Amount of substance per unit volume. Or you can just say number of mole per liter of solution. But if you think you are going to get confused, all you're going to say is number of mole per unit volume. Let's write here moles per unit volume. And then you will get the marks. You will get the marks. And this one is coming from the formula. That definition is from the formula. Nothing to say about it. Calculate the concentration of hydrochloric acid solution. Okay, so to answer this question, this is the reaction. Let's write what we have. We know that 20 grams, the mass of copper is equal to 20 grams, all right? And it reacts completely. Completely. That is important. It reacted completely. They want to know what is the concentration of the hydrochloric acid. This is the question. So now we're going back here to say, and remember the definition, that concentration is equal to the number of mole divided by volume. But we don't have the number of mole. So how are we going to do this one? We first of all want to calculate the number of mole of what they gave us. So we're going to calculate the number of mole of this one. Step 1, number of mole of copper. Alright, so how to calculate the number of mole of copper? They gave us mass, so number of mole is equal to mass divided by molar mass. And then this one is equal to 20 divided by 63.5. Remember, we're working for copper. This is for copper. Okay, so when you solve this one, you will get 0.315. I'm going to leave it there. 315 more. That is step 1. What we are going to do now? Step 2. Step 2, we're going for ratio. Ratio will help us to get the number of mole we're looking for. So we're going to go for ratio. Ratio of what? Of copper to HCl. That is the ratio we are looking for, HCl. The ratios are the numbers at the front. So the ratios are going to be given by 2, and in this case is 1. Alright? So it's 1:2. That is the ratio. What is the number of mole for copper? Is 0.315. Then how much will be the number of mole of hydrochloric acid? And you need to do cross product here. Okay? So the number of mole of hydrochloric acid will be equal to 2 times 0.3. This number is the one we gave us. 315. Number of mole is equal to 0.63 mole. This is the number of mole of hydrochloric acid. This one is what we're looking for there. And then we're nearly done. All we have to do is to substitute. What is the number of mole? 0.63. The volume is given, but let's point something out here. This volume must be in decimeter cubic. All right, in this question they are telling us that the volume is equal to 250 centimeter cubic. So let's write it here in the data here. The volume is equal to 250 centimeter cubic. How do you convert? You divide by 1,000. So it's 250 divided by 1,000, and that will give you 0.25 cubic decimeter. That is the volume we are going to be substituting. And then if you substitute, that one is 0.25 is equal to 2.52 mole per decimeter cubic. Now, something important. This number, this final answer may have tiny difference. And that have to do with how many numbers after the comma you round off here, as well as here. Okay, that is the main difference there. It depends on how many sizes after the comma you use there. You should not round off actually. That will be the correct way. Anyway, if you do that, you get 1 for this formula, 1 for this substitution, 1 for using the ratio, 1 for the ratio, 1 for this formula of concentration, 1 for the substitution, and 1 for the final answer. And this is the end of the question. It's a very good question to start practicing stoichiometric. And there is a total of 14 marks for this question. Guys, thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.